Hello, my name is Bernhard Klingenberg, and I'll be talking to you guys about a software called Unity 3D. And specifically in this lesson, I'll be going over Unity 3D's abilities with particle effects and ray tracing. So first, I'd like to discuss a little bit about what Unity 3D is and the basics of it. So the developers of Unity 3D really wanted to create something that would allow people who aren't professional game developers the ability to get an idea of what it would be like to be a game developer. So they created this software that is all inclusive, and if someone downloads it, they can open it and be able to create their own game on the spot right there. The benefit that departs Unity from other types of software is the community that's based around it. Unity's been around for a while, and through that, the developers have allowed people to use forums, comments, and collaboration to be able to develop a nice, strong community around this software. So if someone around the world is trying to figure out a problem, they can post on the Unity forums, and everyone who's ever been involved with Unity has the ability to either answer the question or provide feedback, and it's really beneficial to help develop these different type of game developers who are more used to working in a collaborative environment. Per the people who come out of college getting their degree in computer science, who probably have not had as much experience working in a group like this. And even myself, in working with Unity, I've utilized the forums a lot because I've had a lot of questions about scripting and different aspects that Unity uses, textures and different types of objects in it. And it's been really helpful as per something that you're just kind of thrown into and you're told to just figure it out on your own. So in Unity, it has everything up to 3D models, preset scripts and code that you can use, a lot of packages that include great textures, materials, and terrains that you can use, where you can they have certain packages that you can import which contain all these different types of materials and objects that you can just place in the environment, and you almost have a pre-made game right there. And then the fun is being able to either make your own stuff, or if you have a little bit of tech knowledge, to write your own scripts to interact with the objects in the environment. It gets really cool and it's really fun. So specifically, I'm going to be talking about two a little more technical parts that Unity has. So Unity has particle effects and ray tracing. And what those are is those are more assets that are used to help make a game look more professional. They're not 100% necessary in the game because you can have a very basic game that doesn't utilize any particle effects or ray tracing. But if you want your game to look really industry professional, you will utilize these effects very frequently. So first of all, particle effects. When you think of particle effects, you think of like in some kind of science, you learn about particles floating around. You see dust particles and things like that. So Unity has this setting that has particle effects, which include particle systems and particle emitters. And what they're used to create effects like fire, smoke, different ambient kind of particles, dust, things that really add to your game to make it look more realistic. And so with Unity, it has things like the particle system and particle emitters. The particle system is very simple. It's just one object that you put in the environment, and you have a bunch of different attributes that you can change to make it act how you want it. This is for more simple, if you want to do simple smoke, or simple kind of like dust flurries, or even underwater. You get kind of the water little particles that kind of swoosh up to make it look like murky water. That's usually what particle systems are. They have different assets that you can mess with, like the emission, which is like how many go on at once. You have the shape, so it can go as like a cone, or it can be like a sphere. And then the most important part is kind of how it changes over time. This is what gives particles a little bit more life, because you never just see something that just is like, it starts as a particle and it's the same way at the end. And in the world, you got things that kind of change over time. So Unity has used gradients and linear mapping to make their particle effects a little more realistic. So they have a couple settings, like you can force over lifetime, color, and size over lifetime. and lifetime is just how long the particle is in the environment at one time. And so you can actually go into the editor and you can use the different settings that they give you and actually change the curve that the game engine then uses to calculate the particles. So if you have your size over lifetime, setting, and you have it set to size 1 at the beginning and then size 20 at the end, as the particle goes over time, it's going to get bigger and bigger and bigger. And that's good for smoke. For smoke, it starts in a central location and then it expands out. So what you want to do is you want to change the curves so it's set up so that it expands over time. And even in addition to that, you can add a setting for the color over lifetime, where color has like RGB, red, green, blue, but it also has alpha, which is transparency. So with that, you can change the color over time so it actually is transparent at the beginning, and then you can actually see the smoke, but then as it gets farther up and bigger, it disappears as smoke naturally does. You don't just have a puff of smoke going at once. You got to have those transitions in the environment, which make it realistic. So that's just particle systems. Unity offers then a whole nother type of particle emitter, which is a lot more technical and includes a lot of different attributes connected to it. Particle emitter includes different assets, like you can have either ellipsoid particle emitter or mesh particle emitter. You have the particle animator and then the particle renderer. Now you need all three of these in order for the particle to show up in the environment, because all three work together. The emitter is, just as we've been talking about, kind of emission, the thing that makes the particles. So in that you have a bunch of different fields: max, min, rotation, size, everything that you can change in the emitter. And then you have the particle animator, which is kind of why I was talking about the curves and the particle systems, how you can kind of start with size 1 and go to size 20. And so the particle animator is a lot more in-depth and includes color pickers as well as like size, speed, rotation. So it's just a little more extensive on that system than just the particle system. And then finally you have the particle renderer, which, if you already don't know, rendering is what is actually seen in a final game product. So the particle renderer is actually where you can add different materials, different colors, and different more fancy looking stuff to your particles to make them look more realistic. And with the particle renderer, you have a lot more wiggle room than just with a particle system. In the system, yeah, you can change the color and maybe you can put a certain texture on it, but the particle renderer allows you to do different like UV texture maps, which allow you to do kind of like the GIF animations with like it changes, each particle has an animation to it. So especially when you're doing something like fire or something that's really sporadic, this is very helpful because then you can kind of get a lot of cool flurries going on. So all those different things work together in the particle emitter that really make it look more realistic than just a particle system. So that comes with a lot of practice, and there's a lot of fields that you kind of have to understand how each one interacts with each other, and then you have to use that in effective ways in your game environment. And it's really helpful, but it's really big, so you really have to have a good grasp on it, and I'm going to do a little example of that in a little bit. So in Unity, when it comes to particle effects, you get two different types. You got particle systems and particle emitters. So the first one we're going to be talking about is a particle system. So if you go into Game Object, create other particle system, Unity will create a little particle system for you. And this is for the next tutorial, so we'll hide that. So if you see, it's a very simple, just particles kind of emitting in space, and it's very simple. It's not as complicated as the other particle effect that they have. But in the particle system, they do give you a good amount of settings. You've got all these different things. It's duration, start, lifetime speed, size, rotation, and then ways you can change it. So one of the main things about a particle system to remember is the size, the speed, and lifetime. lifetime is how long the particles are going to be floating away. So you see right now we have 5. If we increase this to 10, the particles are going to extend farther out. And if we bring it back down to like 4, you see the particles are going to dissipate much quicker. So this is good when you're trying to make something that's either widespread or more compact. And start speed is just going to be how fast the particles move. So if you start increasing the speed, you see the particles are more dispersed quickly, and also it looks like they disperse in a bigger area. So with that, in addition to the lifetime, you can have particles going everywhere. And the last one is size. Right now our size is 1. If we increase this to 3, see the particles are much bigger and much more noticeable. So with those, you also have your start color. So if you go to color, it gives you a nice little color selector, and you can kind of drag around, see which color you want. You know, if this was smoke, we'd probably do a gray. So you see, just change the color. But that is pretty boring. You don't really see many plain effects like this. So if we wanted to make something more like, say we wanted to get this tree to look like it was on fire. So with these manipulators, we can kind of move it around in the terrain. So let's see, let's move him right near this tree. So if we look at that, so he's pretty much there. So first we'll do the smoke. So the smoke will be towards the top, okay? And so this is pretty thin smoke. So we want something kind of more thick. So to do that, you know, we'd want to, first, I would maybe decrease the speed because smoke does not move that fast. So maybe a little faster than that. Oh, that's the size. So increase maybe. Okay, maybe speeds like that. Maybe increase the size a little bit because, you know, we need a thick, kind of just need a thick cloud for the smoke. Okay. That's not looking too bad right now. And then, so then down here we have some of our additional effects we can do to make it look much better. So one is emission, which emission is just how many particles are made at the beginning of its lifetime. So right now we have 10. So you can actually see it's better when the size is smaller. So we'll go back to 1. So if we increase this to like 20, you see a lot more particles are made at the beginning. And this is helpful when we want a nice dense cloud like that. So I'm going to actually put this to 50 and increase our size. There we go. So that's not too shabby. And so that's emission. And shape is kind of which way the particles are going to go. Right now we have a cone, which is really helpful for smoke. But you have all these settings. You can do mesh, so you can choose a mesh from your assets folder. You can do sphere, which will make it kind of disperse like that, which will be good for a different effect. But we'll stick with cone because we want it to go upward like smoke. And then, so velocity over time, this is one of the things where you can use that to kind of change how fast the particles are moving. And over lifetime is, you know, so they'll start at a certain speed at the beginning, but then by the end, they'll be going faster. So it kind of will look like it's accelerating. The one we want to focus on is color. So color over lifetime. So this is good. So you have to actually enable it. So this is good because then we can do some kind of cool different phase of the particles. So right now, we don't have any specific color. So this is the beginning of the lifetime, and this is the end of the lifetime. So we'll actually have our color picker, and we'll start with a nice kind of dark gray. Okay, and then by the end, you know, we don't want white, but we want a little lighter of a gray because it'll start dissipating. And then so these top knobs is actually alpha, and alpha is kind of just like transparency, so how see-through it is. So at the beginning, it's fully visible, which if you think about smoke, usually it's like a little dim at the beginning. So we'll start our alpha channel kind of small, and then by the end, you know, smoke dissipates. So by the end, we want it pretty light too. But you see now we're barely getting anything. So we can actually add a marker in the middle just by clicking, And here we want it fully visible. So there we got our kind of color transition, and as well we have our alpha transition, which kind of gives the smoke a little bit more of a realistic look and feel. So right now that's looking pretty good for smoke, and it's just a smoking tree right now, but we'll probably need to finesse this a little bit, make it a little bit more centered. But that's a really basic kind of smoke emitter you can do with a particle system. And so that's looking pretty good. And so particle systems is the much simpler one that Uni offers, but they also offer particle emitters, which is actually a lot more complicated because it gives you a lot of different assets that you can work with. So in my hierarchy, I actually have an example. It's hidden right now, but as you can see, there's 3 different assets to it, and each of these has different functionalities that particle emitters allow you to have. So if I actually show you this, if I unhide it, see, it's right here. So as you can see, this is a lot more realistic. This looks a lot more like fire. And so in here we have one that's the inner core, which is a lot of the fire in the center. We have the outer core that's kind of more the fire towards the bottom. And then of course we have our smoke. So each of these is a particle emitter. And as you see in the side, we don't have the same user interface as the particle system had. As you see, it's a lot streamlined, more simple, and for particle emitters, we have one that's called ellipsoid particle emitter. And then we have a particle animator, and then finally a particle renderer. So each 3 of these aspects actually give you a particle emitter. You need all 3 for this to work. And, there's a different one. Instead of ellipsoid, you can do like mesh, particle emitter, or different things like that. But we'll use ellipsoid for this example. And so as you see, we got a lot of different attributes that we can mess with. Size, max size, we already know about that. Energy is similar to velocity that we talked about in the particle system. So energy is just kind of like how fast the particles are moving. And this one, instead of giving you a timeline, it gives you a minimum and a maximum. So it'll actually randomly generate it for each particle on its own, which makes it look a lot more realistic, which is the benefit of having this kind of system. And you have so world velocity is like in relationship to the entire environment, and then local velocity is to the object itself, which we don't use any of these aspects for this fire emitter. So we also have random angular velocity. So that's kind of like, as you see, the little boxes kind of show you each particle, and you see they're kind of twisting, which is something we did not get with the particle system. That one was just kind of more streamlined. But for the emitter, we kind of get a nice twisting effect, which makes it look a lot more realistic. So that's kind of the particle emitter. And then so the next one is the animator. So this is kind of similar to when we did the color over lifetime in the particle system. So the particle animator, asks you if you want it to receive shadows, and it actually asks you for a material. So the benefit of a particle renderer, I was at particle animator. So here we have different colors that we can do, and as you can see, the black bars is the alpha. So if you look, we're actually doing it so it'll start from 0 and it'll go through 4 in its lifetime. So each particle is going through these different color settings, which they're all white because, as I said, we have a material attached to our particles instead of just a color, actually. So actually, as you see with these different colors, it's actually just changing the alpha channel of it, which is, if you look closely, I'll actually hide all the other ones so we can see this a lot easier. So if you see, it's kind of fading out as it goes up, and it's very subtle. Like it fades in when it starts, and it kind of goes, and then it fades out. So that's what this is doing. And again, we have our rotation, which is very important, and then we have our size grow. So you see we actually have a negative value, which means it'll actually shrink as it goes up. So as you see in the bottom, it's kind of twisting and it's going, but the particles are actually smaller at the top than when they originate. So that's the point of the size grow setting. And so the one that I jumped ahead to is particle renderer, which is very important because, like I said, in the particle system, we just had like round particles, and you could change the material to them, but usually it's you have to import a package that's the particles package, and they usually have, like, as you see here, like a sparkles or spark, which we could use for fire, but that's not really going to be that beneficial. So I actually downloaded a package that had a bunch of fire materials and assigned it to this one renderer. So each particle is going to have this material, which is flame D, which has this image, which is just a fire. So if you look really close, you know, this isn't actually moving. Each of these particles is just this image, and it's just kind of rotating and like changing. So that's the benefit of particle renderer. And so as you see, it's just you assign the material and it'll just pop up. UV animation is if in Unity you can actually have an image that's a bunch of different like thumbnails on it, and then you can actually animate it with this setting, which is a little harder to do, but if you want something really sophisticated, it'll work really well. So that's kind of what goes into a particle emitter, and they're a lot more complicated, but they're a lot more helpful. So all the outer core and then the smoke, it's all the same thing, but with just modified settings. Like the smoke, you can see it goes a lot higher, it's a lot slower. So if we actually walk around our environment, we'll be able to see kind of the fire. So if we walk around, so you see the fire, it's hovering right now, but like it looks really good and really nice. And that looks like a legit fire that we can have. Our tree isn't smoking right now, but these are some of the things that you can do with particle systems and particle emitters in Unity, which really help with your game and make it look a lot more realistic. Even if don't have a lot of time or doing a professional game, it's just really fun to kind of mess around with these effects to see what stuff you can do, because it's just the opportunities are endless with Unity, and it does a great job at making it easy to use as well. The next aspect of Unity I'm going to be talking about is its ray tracing and light mapping capabilities. Now, this might not sound as exciting as particle effects, but it's almost just as important. So, Unity's developed its own light mapping engine called Beast, and Beast was developed to be very robust and very strong, because light mapping can take a long time, especially depending if you have a lot of stuff in your environment. Now, you might be a little confused about me keep saying light mapping and ray tracing, and basically what these things are is they're things that are used in a game environment to help create realistic lighting and shadows. As you see behind me, the curtains, there's shadows on the curtains, there's a shadow on my face. If this was a game environment and I had a light source right above me, the light source would be projected on me, but I would have to tell the light source, hey, when you look at this object, you got to draw these shadows on me. Because it's not naturally going to do that, because the nature of a software is it just does what it's programmed to do. So you have to actually program this stuff into it. That's what ray tracing is. Ray tracing is a certain type of mathematics where people have used calculations to say, like, okay, if you have the object right here and you have the light source right here, when the light, okay, I'm gonna cut right here. So if you have the object here and the light source here, the light source is going to send a ray to the object. And then depending on where the ray hits the object, it'll calculate the angle and then project a shadow to go according to that calculation. And that's what ray tracing is. The computer is tracing the light rays and then rendering out a shadow to go in congruence with those calculations. And that's a lot easier than in older technology. They had some other way of doing it which wasn't as efficient. This is a very efficient way to make shadows. And shadows are key, because if you don't have shadows, an environment does not look realistic. Because let's be honest, whenever you're in an environment, there's shadows, there's a light source. It gives it more of a realistic effect. So with that, you in your cut here and there where I paused. Check my phone real quick. It is Walter. Hey, tell me again what time tonight. Gotta just text this. I don't want to stop. I guess I can just stop. So Unity's light engine is Beast. And with Beast, you can actually light map your scene before you actually export your game. And this helps to actually, before you even start the game, you select all your objects you want to light map. You actually tell Beast, okay, bake the scene. And when it bakes it, it goes through all the calculations, it finds all the light sources, and then it actually draws the shadows out for you on its own. So that when you play the game, the computer doesn't have to render out any shadows because the shadows are already on the environment. So this alleviates a lot of processing power and lets your game run a lot smoother. And not many people who start using Unity will use this right away because they're going to be doing very simple things. But especially for me, my final project is a Unity game, and we noticed that as we were adding more buildings and more people in the environment, we were getting a lot more lag. So now I realized, hey, if we do light mapping, we'll save ourselves a lot of processing power and make our game run a lot smoother. And it did. It worked really well. And so this is something that is very good to know and will help make your game run a lot smoother and hopefully be a lot more successful. So here's our tutorial on actual light mapping in Unity. So I opened up a similar environment that I did with the particle effects, but as you see here, I actually added a couple buildings and a couple more trees. And so this is going to help us because then we'll actually see how Unity works with different meshes and trees with light mapping. So kind of can look around, and I have all my things right here in my hierarchy. These are all parts of the buildings. So the way the buildings are set up is different parts of them are different types of mesh. So you got braces, you got a door, planks, roof, and then you have an object that's just a wood house. I have my light source right here, which is all the way at the top. Right now it's all set up with settings that I want to light map with. So if I actually run the game, I have just a first-person controller in the environment. So I can just walk around, and I have very basic shadows. And so the shadows are a little softer, they're nice looking, they look very realistic. But as you see what I was talking about, as I walk, the shadows are rendered as I walk. So that's not very realistic, because you don't walk around and then shadows appear as you walk. Shadows are there from the beginning. So that's when the light mapping comes in handy, and we'll actually light map our environment so that the computer doesn't have to trace these shadows as I walk around. So first, I'm going to set up our light source. So I'm just going to remove this. So as you see, it made our environment very dark because we have no light source now. And so obviously we'll have no shadows either. So I'm going to go up to Game Object, Create Other, and then do a Directional Light. Now, point light, spotlight, area light, they're all good for specific inside lighting, but directional light is best if you want to do outside ambient lighting. So I do directional light, and it'll just pop up wherever my cursor was. So now it's right smack dab in the middle. And an interesting thing Unity does with lights is that the Y position actually doesn't affect the light source. You see, if I move my light source up and down, it doesn't matter. It's more when I move it left to right or rotate it where it actually affects the terrain. So that's kind of an interesting thing. So I'm actually going to move my light. So I'm going to get an upper top view. And I'm going to move him to one of the corners. And then he's going to be up because he's going to act as the sun. So I'm going to make sure he's set up. Come back a little bit more. And now I'm going to angle him. I'll just press the R tool to get to the rotating. then kind of just move him so he's kind of pointing down like that. So now let's check out our environment. So we can see what's going on. We can see stuff, but we don't got any shadows. So it looks okay, but we got nothing realistic looking. So that is in one of the settings for our light. Actually, we have not selected any shadows in our shadow type, so we want to change that. So all you gotta do is change it to hard or soft shadows. So hard shadows means that it'll be super strong and super dark. If we switch it to soft shadows, it'll be a lot less harsh, which makes more sense. Since our light source is so far away, we want soft shadows because they're going to be very fuzzy. And as for the color, if you think about it, the sun isn't exactly white. It has a little bit of a yellow hue to it. So let's actually change our color, kind of find our yellow, kind of bring him kind of over to there. We don't want it too yellow because then we'll get a weird yellow hue. But that'll give it more of a natural sun-looking color. And so we have soft shadows. We have strength is 1. So as you see here, this is our preview. We have a pretty dark shadow. So if I start bringing this number down, if you look, the shadow starts getting less intense, which this is more accurate to how shadows look in a real environment. So I want to make, let's put this to 0.5. Half of what it was, which is nice. That's a nice kind of see-through color. Now, resolution is how crisp the shadow is going to be. Right now we're using quality settings. So we can use low, medium, high, or very high. If we do very high, that means the shadows are going to be very crisp and easy to see. But kind of like I said, our light source is far away, so we want kind of fuzzy looking. So we want actually low resolution. So you see it's kind of less crisp. And this will actually also help with our light mapping because it won't take as long because we're not doing high resolution images. And they give you some extra stuff you can do. You can draw a halo, which is actually kind of, if you look at a camera that's looking at the sun, it kind of has those rings around it. And that's kind of what a halo is. So let's draw a halo and then a flare. So let's pick a flare, which is when the camera is actually focused on the directional light, this is what the software will render out. So you can do like a zoom, a small flare, or a sun. So I'm going to do sun because obviously this light source is acting as our sun. So if I press play, we should be able to see our shadows now. So yeah, we got our shadows, and if I look up, you see there's my sun right there. And you see it's drawing the rays around it, which is really cool looking. So we got our shadows, but again, we're still getting the rendering, which we do not want that at all. So now what we're going to do, we're going to get our scene set up to actually light map it. So to do that, you can go to your light mapping tab. Right now we're in the inspector, so to do that, you can go to window, and then go to light mapping. So I have mine right here already, but if you don't, it'll pop up in a separate window. And here we have 3 tabs. We have object, bake, and map. So object is where you will actually be able to select your objects in your hierarchy and then select how you want them to be associated with your light mapping. So if you have a really extensive hierarchy, they have filters. You can do lights, renderers, and terrains. I don't have much in my environment, so I don't really need to use those, so I'll just do all. So this gives you some ideas for the directional light, but we actually don't want to bake the directional light. We want to bake our objects. So the key thing you need to tell Unity is what objects are going to move and what objects aren't going to move. So the only object that's moving is our first-person controller. So this is the one thing we don't want to light map. So everything else, though, I do. So to tell it, I have to tell it that it's static. So you see here, we get the setting light map static. And right now it's not checked. So right now Unity is thinking that this object can move at some point. So Unity is not going to light map an object that'll move because that defeats the purpose. The whole point of light mapping is so that it'll actually draw the shadows on the terrain and leave it there, so it won't have to actually re-render a shadow. So I want to tell it, okay, so this is static, so I'll click that. So I want to do this for all my objects that are static. So my wood house, that is static as well. Terrain, it's already set as light matte static, which is perfect. So I did this one. Let's do the roof. Do the planks. The bracer. And all this is just telling the software, hey, these things aren't moving, so whenever there's a ray trace shadow on it, draw it on the terrain or on the according meshes. So it says object size and light map has reached the max atlas size. So if you look down, so you have light map index, which tells you what number it is in the light map, and tiling is kind of how big the light map is. So you can have multiple light maps for multiple objects. If you have specific light maps for objects, you can actually put that into the inspector. If you actually go, you see I have my material, my bracers div for the CH braces, which is this guy. Right now it's a bump diffuse, but you can actually go all the way down to legacy shaders, light mapped, and then you can choose one, which will actually add a setting to main color, normal map, and then light map. So you actually put a specific light map onto each mesh if you want and if it's necessary. But if we just have one light source, then we can just light map our terrain. So I selected all these objects as static, which is perfect. So now I want to go to bake. So in bake is where I define the specific settings for beast to actually bake the shadows. So I want to do dual light maps because I want it to bake for shadows in the front and in the back. I want to do 2 light maps so I have a lot better coverage of the shadows in my environment. Quality, I'm going to keep at low because I don't really need a high quality. Now, ambient occlusion. This is kind of a new, we haven't talked about this concept, but occlusion is what computer software uses to render out kind of the ambient light that's in our normal environment. If you're looking at a building, so if you have a building and if you look at a corner of a building, usually if it's a corner, let's see if I can, the church has a good example. So if you look at a building and it has a corner like this corner would normally actually have so with ambient inclusion, if we had ambient inclusion set up in this corner, we'd have a little bit more shadow and a little bit more like a fuzziness, because that's just kind of how light naturally goes into corners. But computers aren't that smart, they're not programmed that way, so we actually don't get that. So that's why they give you an extra setting for ambient inclusion. And the best distance to do is about 1.5. And that's about how far the occlusion rays will shoot out. And so if you don't set a max distance, they'll shoot out super far and you'll get really blown out corners which are not realistic looking. All our other settings should be set if we just double check to make sure it's all static. So we just go to bake, have all our settings, and we want to bake the entire scene. You can just bake selected if you want, but since we chose all of our objects that are static, we can bake the entire scene. So click this, and this will actually take quite some time, so you want to let it go for a while. So with ambient inclusion, if we had ambient inclusion set up in this corner, we'd have a little bit more shadow and a little bit more like a fuzziness, because that's just kind of how light naturally goes into corners. But computers aren't that smart, and they're not programmed that way, so we actually don't get that. So that's why they give you an extra setting for ambient inclusion. And the best distance to do is about 1.5. And that's about how far the occlusion rays will shoot out. And so if you don't set a max distance, they'll shoot out super far, and you'll get really blown out corners, which are not realistic looking. All our other settings should be set. If we just double check to make sure it's all static. So we just go to bake, have all our settings, and we want to bake the entire scene. You can just bake selected if you want, but since we chose all of our objects that are static, we can bake the entire scene. So click this, and this will actually take quite some time, so you want to let it go for a while. So now, after all the processing, our lights are finally set up and our shadows have been baked. So if you see here, you have a preview of your shadows. So this is like the terrain, and these are all the different meshes that have shadows on them. So if you look here, we've got the shadows that are being showed, we've got our trees, and so we got a little bit of a problem here, where it seems like we did not calculate this part of the mesh. So we told it was light map, but for some reason our light map decided to not light map that. So that's just kind of guessing and checking. I'm not going to redo it because then it'll take a whole long time. But now if we run the game, we should be able to walk around without the shadows popping up. And they should all just be there. So yeah, you see there, like far away, all the shadows are there. There's no walking and waiting for the shadows to appear. They're all just there, which is a lot more realistic. So, and also my computer is not thinking nearly as hard with all these shadows light mapped. That tree looks pretty good. It's pretty nice. And so the reason it looks like that, kind of pixely, that maybe is a little too much, because we said it was low resolution, and we didn't set it too high, so that might be a little too much. We might want to kind of fix that and make that a little bit more clear. But light mapping, it just kind of takes some time to figure out the settings that are right for your environment and for your different objects. But this can really help your game run more smoothly, be more realistic, and especially for inside lighting when it comes to like a dingy doctor's office or like a sunlit living room. That's kind of the different things that the light mapping lets you do. So thank you for listening. I hope I was helpful, and hope that this tutorial has kind of helped you learn a little bit about Unity's particle effects and light mapping capabilities, and happy hunting and happy game making.